So we're on page 5 of the notes, and the big push for today is that you not overthink this material. We're going to be looking at standard 4.2. We'll talk about graphs of polynomials, how to read a graph, how to talk about a graph. And one of the things, there's not really lots to say about graphs. Like, they're pretty boring stuff. But things people care about are like, hey, when's that graph going up? When's that graph going down? When's that graph not going up or down at all? Like, those are the sorts of statements we can make. And it is as straightforward as you can possibly imagine. I did make a better copy of the graph for this digital notes, but this is what your graph is supposed to look like. And example 4 says, let's use interval notation to describe where the function is strictly increasing. I won't always use the word strictly. I just threw the word strictly in there because sometimes mathematicians do that. But let's not overthink this, right? Here's a graph. If I were to say to you, kids, where is this graph increasing? You'd be like, Mr. Depsick, please, don't insult me. I can see it's increasing here and here. So the only thing that's difficult now for people, and everyone messes this up the first time, when you tell someone, another math nerd, or you tell a scientist where a function's increasing, we always refer to the x values for which the y values are increasing. You want to give me the x value. So we're going to use interval notation to say the x values for which y is increasing. So I thought I would just write that out on the notes themselves. You might want to pause for a moment and jot that down yourself. But we're going to look at these pink regions where the graph is clearly going up, obviously going up. And we're going to make a note of where the endpoints are. It starts here and it ends here. So the point here is -7, -3. That's this guy's coordinate. And the point here is -6, 2. And I'm going to use interval notation to describe these x values right here, from -7 to -6. These are the x values for which the function goes up. So my interval notation is going to be like as low as -7, that's the x value on the leftmost point, up to -6, that's the x value on the rightmost point. That's one interval of increase. For the second interval of increase, if I'm making sense, maybe you can pause and try and think about it yourself before I do it. But I want to look at the endpoints of where this little pink segment begins and ends. And I would say it's from like this point, from this x value to this x value. That's where the graph's going up. From +3, this guy's x value, up until this guy's x value, 5. And that's basically it. Now, when you look at the answer, you take a step back and you look at the answer, it might make your teeth itch. It might not feel so great because it looks like I wrote down a couple other ordered pairs. It looks like I wrote down a point, -7, -6, and 3, 5, which would be over here somewhere. But that's not, like, no one who's asking you this type of question is going to read this answer and think you mean a point. And you are going to have to fight your own instincts because, what are you, like 16, 17? Your whole life, when you've seen something like this, it meant put a dot on the graph. But that's not what this means. Based on the context of this question, interval notation, we'll know what this means. We'll know the graph's going up. As soon as x is -7, the graph's increasing up until x is -6. And then as soon as x is 3, the function's increasing until the x value is 5. So not so bad. Let's try the next example together. Chew on this a little bit, think about it. It's a little awkward. And the next example is going to be pretty similar to this one.